time.
Okay.
I think the same mail ID will be reflected in your account.
Yes, yes.
So please change my mail ID. Then only I can able to reach the material, sir.
Okay.
I will post my mail ID again through WhatsApp, sir. To
Okay,
you
you
personally, in
your
person.
mail ID through WhatsApp, or you can mail me directly.
To whom, sir? To you. Yeah.
Yes.
I will put my application number and I will try to mail by today, or
Okay.
if not possible tomorrow, because I am not having laptop now.
Okay, okay, no issues.
After completing these classes, also tomorrow I will mail you, sir.
Okay, okay.
Thank you, sir.
Hello, Sagar sir.
Yes.
Sir, whatever no responses I'm sending as a feedback, I'm getting reply of all those on my email, but the content which you have shared, I have not received, sir.
Okay. So I'll check.
Yes, sir.
Hello,
Hello.
this is Dr. Vaijayanti Deshpande. I have not also received the materials.
Okay, I think those who have not received, there is correction in their mail ID only.
No,
Shared material to all 696 participants.
so I get
Sir,
the feedback response on the same email.
Okay, but I think there is some correction, means a dot or something like that.
So shall I send it?
Sir, send it to my WhatsApp.
Your
sir,
WhatsApp.
You are
तुमचा
in, I
WhatsApp.
think you are in group, ATAL FDP group
Yeah,
23 to 28. So send your
yeah.
email
Okay.
to that group only.
Okay, sir.
Okay, sir. Okay. Okay. Thank you.
Wankhede sir, if possible, we can paste that drive link in the chat box.
No, I have already pasted the drive link in the chat box yesterday.
For accessing the study material, you can paste the drive link in the chat box, not for feedback, for accessing the
No.
study
I
material.
have already shared that drive link yesterday also in chat box.
So once again, you share it. So those who are not getting on mail, they can get it from chat box.
I think in that case, we need to you need to provide the access also. Yesterday I was clicked that link, but access was not there.
Wankhede sir, keep it open to everyone with a link. You can have that option.
Good evening, madam. I am also not received any mail from you, madam.
Yeah, sir, we'll try to give the access and we will put the link in the chat box only.
Yeah, it is
So that
better.
you need not to wait for an email.
Okay, okay, that's better. No?
Ah.
Thank you.
Hello, Varsha ma'am. Hello.
Madam.
Swapnil sir is going to join within the 10 minutes. So we will wait for 10 minutes. Hello.
Yes, ma'am. I got the call from Vivek sir. So
Yeah. Okay.
Hello, I hope I'm audible.
yes, sir. Please tell me.
Yeah, thank you for your confirmation. I'll share the screen and do let me.
Sir, let me introduce you first and then we will start with the session. Fine?
Okay.
Okay. So, very good evening to everyone. I am delighted to welcome you all to the first session of day 5 of ATAL FDP on electric vehicle technology. This evening, we will dive into the world of hybrid powertrains, a key technology which is driving the evolution of sustainable mobility solutions. We are honored to have with us Mr. Swapnil Wadkar, manager at ZF India Pune, to deliver today's first session. Swapnil sir is highly experienced professional with a 20 years of experience in engineering field. He specializes in model-based software development for automatic transmission. His extensive expertise encompasses the MATLAB Simulink, CAE and CFD modeling, thermofluid analysis, and hybrid vehicle technologies. Swapnil sir holds many certifications and mainly ISO 26262 for functional safety, and he has deep knowledge of automotive systems. Swapnil sir has made a significant contribution to the development of hybrid and electric vehicle powertrains, which mainly include the technical trainings, innovation proposals, and e-axle solutions. His academic accomplishments include an MTech in heat power engineering, a MicroMaster in emerging automotive technologies from Chalmers University, Sweden. Currently, he is studying at MIT Cambridge. He has also published books and research papers on mechanical systems, CFD, and automotive innovations. His work on hybrid powertrain diagnostic, functional safety, and system optimization has earned him a wide recognition. So, through this session, I hope you all will get acquainted with the hybrid powertrains and their role in the automotive industries. So, let us extend a warm welcome to Swapnil sir, and we look forward to your session, sir, which will surely bring both enlightening and inspiring thoughts. So, thank you, sir, for joining with us today, and over to you, sir.
Okay. Yeah. Thank you, ma'am, for introduction. Yeah, we will dive into the presentation part. So I will just quickly share the screen. Just do let me know once it is visible. Yeah, I hope screen is visible.
Sir, it is not yet visible to us.
Okay.
Yes, sir, now it is visible.
Okay. So yeah, I'll start with basics of the hybrid powertrain, though we might have been introduced from earlier speakers. I don't have any idea, so I thought like it's better to revive all the fundamentals, which are essential ones, and the things which are basically going to be throughout our sessions are going to be needed, perhaps, so they can facilitate our understanding and maybe effacing the fundamental trains which are currently in market, hybrid powertrain. So I'll start with the introductory part of like EV fundamentals. So yeah, of course, yeah, this is going to be the design outline of the speech today. So basically, I'll be uh, first into this particular PowerPoint presentation. I'll be focusing on these contents like electric cars, EVs, hybrid vehicles, what are basically differences in micro, mild, and full plug-in and range extended ones. Then we will dive into the powertrain parts like the components, system modes, mechanical challenges if there are any, and even like some part of like lithium battery technology also I have tried to cover so that it can enhance our understanding about from where basically the power is coming and how it is going to get delivered to the wheels. So yeah, maybe a topic of interest, another which one is understanding about traction motors. I do represent ZF Incorporation, so which is located in Friedrichshafen, headquartered German solution provider. So we are into like hybrid powertrain. So a quick recapitulation of the products and solutions which we offer into automotive industries. We are tier one suppliers for most of the technologies and all. So that part also I will be in small content. Maybe I'll be just touching upon. So yeah, introductory part about EVs and all. I'll skip the non-essential technical discussions, perhaps like which are very, I mean, not dwelled completely into the core technology and all. So core technology, of course, we will consider. Okay, so we know like it's now nearly a century from automotive progress has been synonymous with internal combustion engines. We have studied them a bit, and we know the fundamental working and all of internal combustion engines. But due to current uh, the global trends, we are into the revolution of EVs, which we call them as electric vehicles. So, like growing demand for cleaner and more efficient motoring solutions, so which has sparked a revolution in vehicle design. So this shift towards like electrification basically is poised to dive into automotive industry into a more sustainable future, leveraging like hybrid and fully electric technologies to reduce emissions and increase efficiencies and all. So perhaps we all know like Tesla's full electric vehicle solutions, basically a major player in EVs market. So which demonstrates advantages of full electrification with high performance EVs like Model S or Model 3 even. And even we know like perhaps with the software solutions like AI and all, and even like quantum computing and all, so there are a bright future for all these terms and technologies and cutting edge things. Okay, so speaking about electric cars, these are perhaps I've just tried to cover those vehicles which are already there in perhaps Indian market, so that we have at least a listing, and in mind we can correlate what and how internally these things are different. So of course we our main focus is into hybrid powertrain, but yeah, before that let's have a recapitulation about and collect whatever is fundamentals which are essential to understand it. Okay, so we know like these EVs have gained significant traction due to their environmentally friendly and cost-effective natures, like Tata Tiago, even Kia and BYD, perhaps Auto 3. So now perhaps across globe, BYD is becoming a global player and a top player into EVs and EV manufacturing part, even trying to challenge Tesla's EV development. So because of the China's battery making technologies and recent trends and all, so yeah, many auto manufacturers across China have grown to that extent, which dominates perhaps now these days electric markets. Yeah, so perhaps we also know like MG and Hyundai Kona, even Volvo XC40. So we know like perhaps this is the pioneering company which focuses mostly on the cutting edge technologies and happen to be like the most what we can say innovative approach taking company, and very proactive into all these system solutions, functional safety solutions and vehicle safety solutions and all. So that way it is considered to be the most reputable company. Okay, so then BYD E6, so these are also available. Jaguar I-Pace, so that is BMW i4 and Mercedes EQS. So all these are list of like electric vehicles. So these are into some kind of a sports segment, Porsche Taycan, and even Mini Cooper. So perhaps some of us know already. So these are ranging from luxurious solutions to like uh, available or quite popular, even though at low price segments about into Indian markets. If we talk about the hybrid and the term hybrid itself, so basically this is what the things which we need to remember. So EVs or electrically chargeable vehicles, what we say. So these are like powerful and fully or partially based on the batteries, and yeah, they run completely on batteries, what we say, pure electric vehicles. So they have only prime mover, which is basically a battery, and sometimes as another version which we say as like range extender ones. So REX is the usually typical term given. For example, like BMW i3 Rex, which is example of range extended hybrids. So we have plug-in hybrid vehicles, PHEVs, what we short. So that's the acronym, and extended was speaking about in electrical vehicles. Yeah, so they offer a blend of technology, which is basically into electric solutions as well as into the like IC engines. So based on that, yeah, we can generate a power and we can transfer it to wheels. So that is also a part of this. Okay, so apart from that, we know like plug-in hybrid vehicles basically where the gasoline engines serve as a backup, basically power source once the electric battery is, we can say, like depleted. So based on that, even there are few algorithms which are currently changing all this scenario and making it more profitable, and perhaps in recent years it will be very interesting one and intriguing one to understand which way this technology is going to change, and we are going to see those, or we are going to witness those changes. Okay, so about hybrid vehicles, so these terms I covered, like electric vehicles basically chargeable, so which requires charging and all. So we will be covering all those basics. Just this is a listing of all the terms here. Pure EVs, so which are like pure electric vehicles. There is no IC engine as such into it. So just based on pure battery power source, it will be driving by some traction motors, the wheels. Okay, across various requirements. Yeah, all different driving modes also. Perhaps in eventual talk we will be trying to cover. Okay, so that is what all electric means, basically battery driven full electric vehicles. Plug-in hybrid, perhaps plug-in hybrid, a pioneer company into this was Toyota, so who shared recently a platform with even Maruti Suzuki cars, sorry. So now hybrid is a technology which is like every auto manufacturer has its own trend towards the PHEVs. Basically, as I told, as we understood this in the context of like pure IC engine based vehicles, so which are driven solely on IC engines, and towards purely electric vehicles. So this is a mediator, which we say as either a plug-in or range extended one, or maybe hybrid vehicles, whether it is a fully or even parallel and all. So all these terms we will see one by one. So that basically into hybrid, once we dive into it, so we need to talk about like what is a micro hybrid, what is a mild hybrid, what is start stop functionality in the hybrid. If there are like this topic is also of key interest perhaps now these days, alternative fuel vehicles, because each and every organization, especially auto segment, is showing up their capabilities into perhaps hydrogen fueled hydrogen power cars and all that. So they need to keep on searching alternatives, so just to get some more efficient and less like emission friendly vehicles, kind of zero emission is the tagline these days all industries use. Even though EVs are not it's a debatable like whether they are really zero emissions or not. But yeah, apart from that, yeah, if we stick to technology and all and its development, yeah, these are the terms. So IC engine, we know like either petrol or diesel is used as a component, even like CNG can be alternative for that. But yeah, so those are like possible things with internal combustion engines, electric quadricycles, motorcycles and all. Again, we have seen this trend as well into market. Whatever technologies earlier used to be for sports vehicles, those came into luxury vehicles. Now those luxury vehicles became like common pass cars, especially an abbreviation used for ordinary passenger cars vehicles, and then it boiled down to the motorcycles. So now these days we also see the motorcycles which are basically driven by EVs and all. Yeah, so about degree of electrification, if we speak, so this basically electrification in vehicles varies from micro hybrids, we will say, or mild hybrid, MHEV, we say, to completely electric ones. So in the range like full hybrids, pure EVs and all, in those steps, we can say. So micro hybrid typically offers start stop functionalities into onto traffic signals and all, so which enhances or at least depletes some fuel consumption rate. So that way, relatively like environmental friendly, we can say. So while full hybrid vehicles, if we speak, so those combine an electric motor and IC engine to work together for optimal performance and efficiency. So even there are like in Mercedes-Benz also offers C-class vehicles which are using this micro hybrid technologies, wherein start-stop functionalities especially are featured to conserve fuel by turning off the engine when car is in idle mode. Okay, so these days, like artificial intelligence is also playing a crucial role into it. So like based on energy management systems, so it can perhaps, so hereafter once we speak about V2X and vehicle communication, so I meant, so then it may be more intriguing to look for these technology clusters maybe, and how they are providing solutions to it. So yeah, this is what I would say, like expected trend, because of, we know, like pandemic period it delayed a bit, but still to somewhat extent still the graph and basically the predictions are almost like identical. Micro hybrid and mild hybrid technology is not new one, so it got introduced into 2000. Earlier we know, perhaps, like uh, there were few vehicles from all luxury segments as well as from Toyota car manufacturers who catered solutions into this segment, micro hybrid and mild hybrid. Then we had in that in between 2000 to 2010 we had this Corolla or Camry and those kind of vehicles, wherein full hybrid technology was already established and was giving good results and outcomes as expected towards energy conservation. Then this trend started especially after pandemic and or near before pandemic, I would say, like wherein plug-in hybrids became a topic of cutting edge technology, and wherein every country started to basically forecast like after 2035, and but yeah, that is what a practice, and they are still going to follow in Europe across. So it has been decided like hereafter, like mostly almost like all European countries will be focusing on more of the kind like EV technologies based on, rather than on hybrid vehicles or fuel based, especially like diesel petrol based vehicles. So yeah, uh, and of course we know like these days as well still it is very challenging for EV technology and all to get established. But yeah, if, of course, like if you have some inputs from China and all the vehicle manufacturers from China, they have established, especially government was very supportive, and they have established some uh, uh, infrastructure which caters this particular segment, starting from charging till towards like whatever, like till even the infrastructure about like providing cross chargings in different vehicles. So manufacturers are different, but yeah, there are conversion or adaptive adapters which will change the structure of charging ports, and it will be able to charge a vehicle. So in short, this is just a small clip about EVs. I hope it plays seamlessly. So this is what basically it will look like on a charging port. If we plug into a port, So of course, a battery slowly will get charged, and that will drive the power towards like traction motors, which will provide a traction force to vehicle, and which will be a prime mover, perhaps we can say. And this part, the white box, may be consisting for range extenders as a blend of IC engine and all that. So yeah, this is what in general EV infrastructure, the charging station and all would be. So this infrastructure development is still a problem in even developed countries like US and Europe. So there still the technology is in question. So that's the reason it is getting prolonged. Otherwise, yeah, we would have stick to those deadlines about 2030 would be the full EVs and all. Yeah. So what are additional, I mean, offerings from the electrification technology is basically it is silent mode, instant power delivery. So like even in China, if you have records about Xiaomi's and Neo's development, so even Dufong. So the way they have catered solutions, especially instant power at the start. So that is basically amazing, and that's why it is still impressing people to go for this EV technology. And all this, of course, without any vibrations. So dazzling performance. So that means like reduced moving parts because there is no IC engine, and more vibrating parts. Even though in range extenders it is, but still it will be like. Will not be hampering that much into performance. So power will be less, I meant. So from micro hybrid to range extended ones. So this is how the vehicles will be categorized: micro hybrid, mild, full, plug-in, and range extended plug-in electric. So these two are pure electric CVs, what we say. Yeah. So this is like what functionalities do they offer? So these are features, start stop functionality. So of course, every segment offers that because it's we are discussing about hybrid, and that's the term. So to assist at the start, and the moment vehicle is stopped at the signal, okay. So then to assist again to generate the sufficient torque at the beginning to move the vehicle. Okay, regenerative braking. So that means some power is generated after braking, which we lose by braking. So in the form of heat. So instead of that, if it is possible to recover that power. So, but in micro hybrid, it is possible. It's not promised in all the manufacturers, but yeah, most of the manufacturers do it. And in hereafter, like mild to pure EV, yes, it is there. Boost, especially during the acceleration mode. So, for example, we can consider the hilly terrain, and wherein we need a support or extra acceleration. So that boost is not available in micro hybrid because of the battery structure and architecture of the micro hybrid vehicle. But yeah, for all others, it is possible. Electric only mode, yeah, it's of course not possible still this or till this particular segment. So full hybrid, yes, it is possible, but again, not promised by all the full hybrid vehicles. Yeah. So plug-in hybrids, yes, it is possible. Electric range, of course, no range because pure electrification is not happened, and we are not considering electric battery as the only prime mover here. Yeah, here it is possible, but only few segments into that. Okay, so for like micro hybrid, what is the primitive technology? I would say like it uses a small electric motor, I would say, to assist with acceleration. So I would show you like over here. So regenerative braking, as I've said, stated like it's possible, but not always. Perhaps like Volkswagen Golf mild hybrid vehicle and all, they use it, but not into micro segment, not much into micro segment for sure. Yeah, here. So sorry, I'm moving front. Yeah, into this like these features, especially during the braking, it may be possible, but yeah, we still have same 12-volt battery architecture. So it's a single battery. That is the primary difference in between micro hybrids and mild hybrids. So they do not need any plugins and all. So their battery is charge during the drivings. So yeah, there are a few even involve developments into this segment again. So every manufacturer has to segment out its vehicle and the segment so that it can basically uh, play a crucial role into a market. Yeah, for mild hybrids, yes, there would be additional difference of like 48-volt battery architecture along with 12 volt. Usually, a mild hybrid will keep both batteries. They will retrieve or preserve the 12 volt battery architecture, as well as in addition to that, they will provide this 48 volt. But yeah, it's considered to be nearby to like 60 volts. Is considered to be the danger part and needs to be catered in different segments. So there are some protocols from safety sides entirely across globe. Every manufacturer industry or manufacturing auto industry has to follow those norms. So this is basically powered by a 48 charged battery system basically to assist IC engine. So yeah, but yeah, unlike in full hybrids, they cannot operate solely on electric mode. That's again a difference in between this and full hybrid. Okay, so here 48-volt battery in between micro and mild is the difference, and here after like uh, the prime mover as a battery is not possible in mild hybrid, so which is possible in full hybrid. So again, they primarily use electric power for starting and accelerating, so that push and all that is possible. Even we can see like fuel consumption gain also 8 to 15%. That is what most of the manufacturers promise. Yeah, again, uh, yeah, there are few battery technologies which we'll be separately discussing upon. Nickel metal hydride is the commonly used and lithium ion. So these are two options which are commonly used in mild hybrid. So these days lithium ion, but yeah, it's expensive one, and we will discuss talk about this technology again there. Yeah, so these are like supportive functionalities, e-charger. So of course, what I was talking about, electrically driven water pump. So this system basically for the cooler and all. Then there would be assistant, especially a push in the support technology, and again power steering. So these functionalities will be taken care by the mild hybrid vehicles on the battery, not driven as like in conventional vehicles by IC engines. So the yellow highlighted parts are basically driven by batteries or powered by batteries rather than IC engine. Okay, so that is how hybrid and degree of hybrid, I guess we can understand now. So this is what even we can see like a torque converter. So the pump which pumps the fluid into torque converter. So this is considered to be the complex device. I can understand, yeah, because it's quite not so intuitive one, and one needs to imagine the fluid flow and all. It's quite that way intricate device, I would say. But yeah, in mild hybrid, yeah, it is there, and that is basically the oil into it is basically taken care by the now by the battery, no more required from the power from the IC engine. Yeah. Full hybrid, of course, it has a small battery architecture. Again, small means what small, and all these norms are again manufacturer to manufacturer. These are different. So Toyota Highlander, perhaps, like if you have seen that vehicle, so that is hybrid. Even Prius or even Camry, these are full hybrid vehicles, so well established into market. And even there are few from, of course, from the luxury segments like Mercedes and BMW parts as well. But yeah, this is what in general the technology will look like. So it will have two motor sets. MG1 and MG2 is the short form, so which we will be in the second presentation we will be looking at. So all the components. So it has, of course, full hybrid has IC engine as well as the battery packs, and along with that, so since it has a capability to power vehicle on purely battery, so that's why it requires electric motors. In between these two motors, there sits a transmission, which I'll be sharing and I'll be discussing. So these are different modes we know, perhaps like combustion engine and electric. So combinedly, a power can be taken from both sources, or either of the sources. So pure EV, combination, or pure IC engine. So all these three modes are possible in full hybrid vehicles. So of course, fuel savings and all, emission norms and all. So it's like 20 to 50% efficiency gains over standard vehicle or petrol and diesel vehicles, conventional vehicles. That means, yeah. So here comes like plug-in hybrid. So which requires a charging, extra charging from the outside source uh, because of the power and or voltage depletion into the battery packs, we can say. So yeah, it can operate solely on electric power for short distance again. So they also have some part of like gasoline engines to extend their range and all, like we call them as a range extender. So that option is there. But yeah, some of the vehicles have only ICE engine, like Tata Nexon, perhaps, you know. So that vehicle is pure EV, no internal combustion engine as such. But yeah, range extended. So like we know the consequences of EVs, pure EVs, plug-in hybrids. That means, but here, yeah, for the additional power can be resourced from the internal combustion engine. So that's why the term is called like range extender ones. So this is what internal combustion engine and its architecture would be. So there will be a lot of control units and processors or microcontrollers which will be communicating completely to the mainframe ECU, and which will be for each and every technology. I would say like there are a lot of engineers who are working on the logics, and even though like you'll be surprised, even we are getting customer queries on Audis and BMWs and even Rolls Royce. So in peculiar functions and all, though almost all operations are addressed, but yeah, there will be some scenarios and test cases wherein even though however sound your technology you make, still there will be quite a bit of room to develop these parts. So in combination, it would be very tricky. Yeah, so these are like terms which are used in degree of electrification. Apart from these fuels and all, we are not going to go into chemical and the chemistry involved in those fuels and all. But yeah, this is what entirely from the mechanical perspective or architecture wise, how the hybrids would look like. So there is something called as a parallel hybrid technology. There is something called as a serial hybrid technology, and there is something called as a power split. So I know like Audi has its own peculiar power split vehicle into it. So each and every manufacturer has its own trends towards the hybrid power generation. So either taking purely based on motors, or IC engine as a support, or IC engine is driving like generator motor here you can see, and then from that AC/DC converter and all. So this part, yeah, we will be discussing next. So that is what a serial hybrid means. So in series, these two are connected. Okay, and power split, basically a power split from IC engine as well as from each of the motor is possible. So in short, I would say. So this is what parallel hybrid architecture. Again, there are few options like usually the degree of parallelization has these terms: P0, P1, P2, P2.5, P3, and P4. So that's why it's very tricky, especially about to speak about the vehicles and all, and what kind of technology they are they are using. So P0 basically is integrated just front end, so like via a belt. So basically that parallelization is power is given to just at the start and stop kind of thing. So we can say P1 is the power, basically E drive, so which is from the battery or from the motor. So that is supporting engine and transmission part in between that. So P2 is also, but after the clutch plate. So that's the difference. P2.5, so again for the transmission inlet side, so it can push it. P3, so it's another level of hybridization, so integrated with transmission. So that means battery power is integrated with transmission. And P4, like four-wheel or assisted, like all-wheel drives, and in those scenarios, P4, that means in addition to that axle and all, so that rear wheels are also supported. But yeah, perhaps almost every one of us knows, like most common segment is this front driven wheels. So that is the common architecture which most of the cars, passenger cars, use because of the less number of components, and it's easy to control, and even oversteering and understeering, perhaps the terms if you know, so to keep a track on that. So yeah, apart from that, this is about serial hybrid technology and the terms related to it. So yeah, it's the same part as we spoke in earlier. Into introduction part, power split technology. Yeah, this is like Volkswagen and Audi Group uses it. So perhaps you might have heard the conglomerations these days. Even just recent news is like Nissan, Mitsubishi, and Honda are going to be conglomerate to each other, so to dominate the market. So each one will be sharing its platform technologies with the others and to enhance the sales of the others. So those are common terms in auto industries. And yeah, so this is about power split. Yeah, we will be talking about that again. So this is overall like a degree of electrification. Perhaps these are different modes which I was speaking of. So creep, especially just because of the play maybe, or engine because of just starting of the engine, the vehicle is moving. Standstill means it's zero, dead stop. Creep, launch means basically we are accelerating, then it starts accelerating. So drive and accelerate. So here, so this whenever we see the slope line, so that means there is some power transfer to the wheels. So these are like maneuvers. And then, so this is typical terms which are used in vehicles and their modes of driving: standstill, creep, launch, drive, and accelerate. Constant driving, so no need to accelerate, it's just at the same position accelerated pedal position is. Then coast down, so basically we are decelerating, but vehicle, because of its inertia and it's running. And this is like brake, so we are reducing the speed. And then standstill means again we are at stop. So these functionalities, how in basically in different segments of hybrid vehicles are supported. So that is what is listed. Yeah, so that was the first part of our presentation. I would go for the second part, which is more into like components and all. So just let me share that part again. So this is from the perspective of like the components which are present into the hybrid powertrain. So I can skip this. So we already have discussed about benefits of hybridization of the vehicles, fuel consumption, acceleration, and also this part we have discussed. Maybe Toyota Prius. We can speak about as an example, like which became synonymous with hybrid technology, and particularly in cities, perhaps like Tokyo and all, which are well developed, where efficiency and reduce emissions are again key. So there it basically it has grown popularity into emerging markets. Even in India we know that it's this technology is coming up. Then there are like predictive maintenance systems. Perhaps those are like assisted from, I would say, these days it would be like hereafter, maybe some AI driven technologies and all will come definitely into it, which will work more into like efficient maintenance, efficient repairs and all. So which will be even suggestions and all that would also be done through some AI techniques. Of course, there are a few models which needs to be trained on that, but yeah, it will work. So this is our important part and basically more interesting topic perhaps. So this is about hybrid powertrain components and its overview. So what are key components into it? So basically like understanding components is crucial. So like typical hybrid powertrain will always have these components like the inverter converter part. Then there would be motors, as I spoke about, MG1 and MG2. So we say like motor generator sets, MG1 and 2. Then mechanical driving units, perhaps we can think about transmission part. Then high voltage systems. So yeah, I was speaking about this. So any vehicle which has a high voltage system above 60, so that is considered to be tackled by these orange uh, a bright orange identifiable color cables, so which speaks about not to touch those cables for users as well as for repair persons. So this is what is global, uh, we can say a term and basically convention followed. Yeah, apart from that, we do have high voltage electrical systems altogether, like control electronics, battery packs, high voltage battery packs basically. And yeah, those control systems would be taking decisions about from where to transfer power, either to activate gear set 1 or gear set 2 and all that. So this entire unit, as I'm saying that as a combined term as inverter converter, so that will be consisting of all our like converters from DC to AC for motor gear sets 1 and 2, MG1 and MG2, I would say hereafter. And which converts or even like converters like AC to DC during regenerative braking, perhaps to again store back or to apply that charge back into high voltage battery packs. So and that is also possible. Like then distributes high voltage via cables to other components, perhaps. So about like vehicles efficiency and functionality of course would be dependent on integration of all these. So of course it's not solely of this. Yeah, we can see some microcontrollers and some PCB designs and all. So basically it is to take decisions. So like this ECU, inverter converter ECU would be sending some signals and will be in communication with central ECU of the vehicle, and which will be taking decisions and all. So yeah, that even communication is also intriguing one. So basically this part of like inverter is critical for converting even batteries DC energy to AC energy for the motors. And while both these MG1 and MG2 manage starting, propulsion, and perhaps even regenerative braking. Yeah, so uh, if we speak about cutting edge technologies, silicon carbide inverters, they improve energy efficiency and reduce weight. So that's why that is also a cutting edge technology, I would say. Even there are few attempts to redesign the algorithms which are a bit being tested and to enhance the power electronics switching efficiencies, so that it would be again consuming as less possible fuel as. Okay, about inverter and converter part, if we speak about, so which is one of the technology we also cater into it, and we do have some development into it. So this sits usually on the top, first of all, the inverter with converter located at the top of transaxle assembly, we can say. So it houses these components like listed like DC-DC converter, perhaps inverter, first of all, even then the booster converter. I would speak about this booster converter, what it is and all, and ECUs along with sensors. So to get some insights from the real environmental conditions, like perhaps temperature sensor, voltage sensor, current sensor from each and every instrument. So so whenever we have electronics components, of course there would be some threshold of working and handling the current and voltage capacity. So that threshold is continuously monitored by these devices, and there is a feedback for that or feedback looping, I would say, for all such intricate components, so which needs to be delicately handled. Yeah, even there are like into these converters and all, like perhaps some of us might be knowing gallium nitride transistors in inverters reduce heat loss a lot. So that's why perhaps like and that is also considered to be the cutting edge. And even optimizing the inverter's real-time performance. We do have real-time environment simulators and all. So yeah, RTEs and all, we do keep track of these and try to optimize their performance internally through codes and all. So for dynamic conditions, of course. So for these DC-DC converters, of course, I spoke about like the steps, basically the high voltage DC down to standard to 12 volt system, which is demonstrated here. So from the battery, and that is needs to be, because each and every component, which is electronic component, has some threshold and working volt basically range when it will be most efficient one. So that charge rate system, so that is what is the one of the goal of this DC-DC converter. So this maintains full operational voltage and current to 12 volt system, including like charging the auxiliary 12 volt battery, as typically there is no conventional alternator installed in full hybrid electric vehicles. So this even DC-DC charger is rated to a certain amperage and output depending on the requirement of electrical and low voltage consumers which are installed. So this also can be combined with converter assembly or installed directly onto high voltage battery packs. So again, there would be various sensors in the inverter and converter assembly, monitors such as like as stated, atmospheric pressures, temperatures, and powertrain components and all. So this basically overall we can see like it steps down high voltage DC to 12 volt system and powering low voltage systems like lighting and infotainment and all those systems, perhaps we can say. Even charges the auxiliary 12 volt battery, eliminating the need for alternator in the hybrid. So that is what is a crucial task which DC-DC converter does. Even for that DC-DC, basically uh, uh,
Swapnil sir, I think you are on mute. Kindly unmute.
I don't know, somebody might have muted because of disturbance. Sorry, I would again cover this booster converter. So basically, this steps up or steps down voltage as required, enhancing the hybrid system's adaptability. So it maximizes the voltages of the MGs and manages battery charging during the operations. So basically, the booster converter, what it does is it is connected to inverter, so has main task of stepping up or boosting. What we say stepping up means the normal high voltage from high voltage battery pack to any voltage level up to the maximum high voltage rating predetermined by the manufacturer. So and when powertrain system requires it, and it also has like booster converter which also has step down high voltage generated by motor generator MG sets to nominal high voltage charging rate for the high voltage battery packs. So that is, these are two main functions of the booster converter, I would say, step up or step down. That's why the term is booster. About mechanical driving units, of course, we are speaking about plug-in hybrid, so naturally it's hybrid, so there would be these components. But yeah, these days manufacturers choose it wisely to optimize the number of components into it. So the mechanical drive units basically uses like compound planetary gear set systems. So you might have observed that. So to connect and disconnect the IC engine with the MGs, motor sets, motor gear sets rather. So MG1 and MG2. So it provide variable ratio, like even torque multiplication. Perhaps those who know how planetary gear set system works and all, depending on the gear ratios and all. So again, this is a peculiarity of a manufacturer to which ratios we can achieve. For our ZF part, I know only 3 planetary gear sets are able to make 8 combinations of gear. So 8 speed gear train, what we say. So based on different combinations we can generate. So that's why people prefer to get attached with, and again, their linearity as well, like easy to adapt with the rotations and all that capability also enhances the power transmission part. So these are basically used in hybrid electric vehicles. So that of course vary in design as per manufacturer. So that is a primary part, one of the primary part. So it provides variable ratio as I've stated. So drive unit is also used for motor RPM limiting, so that if the power demand is less and MG motor gear set is already transferring higher RPM, so that step down is also possible with this gear ratio. Again, also controlled by the main ECU for the hybrid electric powertrain. So that is also comprehensively managed and controlled by the hybrid powertrain systems. So I would say like the ECU gets inputs from different sensors and other ECUs, so which are in communication. So it monitors requests and calculates the required torque and power, and that's how torque multiplication part and even limiting part will also be taken care. Yeah, about these like motor gear sets 1 and 2. So again, there are various configurations of electric motors and generators in use by hybrid electric vehicle manufacturers. So that is also quite vast. So typically there would be MGs which like components, so like motor generators. So they are used to provide the mechanical rotational forces as well as to generate the voltage and current needed for to recharge the high voltage battery packs. So the two main components which that make up these units are wire wound stator part and as well as the rotor part. So again, there are different types and all that into it again. So with typical two motor generator power train, MG1 is used as a main high voltage generating device as well as starting the internal combustion engine. So that is what is the goal of MG1 usually is. And the second, which is MG2, so that is the main motive force driver for the drive wheels. It is powered either by MG1 or by again high voltage battery packs via inverter and converter. So with the assembly, so it can be used as a regenerative for regenerative braking. Sorry, by turning up into generator when the driver begins vehicle's braking action. So that is one of the part usually that is handled by the MG2. So these are two different devices, we would say. Then high voltage battery packs, so which is again considered one of the important part of our hybrid EVs architecture. So like high voltage battery packs, so main provider of power used by the powertrain electrical components. So when there is no electrical power being generated either by MG1 or MG2, in EV mode, especially I'm talking of. So it is recharged either by MG1 or MG2. So like when the conditions permit and when internal combustion engine is operating. So depending on that, the controller module would take an action, and based on that, so it is the performance is already optimized so that there would be less power which is lost and maximum is going to get utilized even though it is in braking braking or in any other form of conditions. Yeah, so again, I spoke about like these are these cables I was talking about. So since it is from battery, so of course it would be high voltage cables. So those would be which are critical ones and needs to be handled very like carefully. So that is how the power management ECU would take action. So there it is located and it would be taking care about all the decisions and all. So those were just the I would say the components which we listed. So in summary, I would say like hybrid powertrain is a kind of a sophisticated system, so that relies on the we can say a synergy of components like IC engines, and then we do have MGs, motor gear set 1 and set 2s, and even high voltage systems. So that is basically a key part. And okay, speaking about these cables, so this is how internally these high voltage power cables would look like. So it's a stack of small wires and basically grouped into it so that they can carry this high voltage system to the location. And it can also be used for fast charging the batteries. So their gauge and all is of course is the design difference, but yeah, colors and their connectors are also different. And there is a standard universally accepted style which is followed by all. So this is how the cables are used, and naturally they are easy to highlight or identify. So that's the typical, I would say, like the system components and all would look like. So now we have discussed about components which are a part of or which make the powertrain or hybrid powertrain. So let us talk about different modes, system modes now, so that we can understand it in much more depth, perhaps. So it would be intriguing to understand like what are different modes and all. So we know like our hybrid powertrain provides us these or caters these particular different modes, I would say. So like system modes, so like as the demand for electrified vehicle continues to rise, so like these modes, their understanding would be of course essential one. And from designing perspective, for the algorithms and all, as well as from uh, learning perspective, I would say. So basically these vehicles operate through a series of modes, we know, like to design the maximum efficiency based on varying driving conditions. So this basically would focus on like how these electric constant velocity transmissions like ECVT, what we say and all, plays a role into powertrain, and basically a central part of I would say like vehicle architecture. So these are based these hybrid trains, powertrains are adjusted based on the driving needs, and which will perhaps more focus is on the fuel efficiency and all. So that would be we are going to address. Okay, so for different modes, let us start with the easiest mode, which is light mode, standing start. So typical mode. So what exactly happens and all. So at light load, like this, the vehicle is starting from the standstill. The hybrid powertrain utilizes electric motor, which is MG2 set 2. So as of course it is for as an example, like, but yeah, of course, as I told you, like different manufacturers use different strategies, but conventionally or most of the manufacturers do follow this. So MG2, which is the sole driving force, like then which the power flows from high voltage battery to inverter and then to MG2. So that is how it propels the vehicle. And if torque demand increases, then our internal combustion engine will play and becomes activated through MG1 then. So that is what is a basic idea is. So which will add additional power to assist MG2. So that is what the light load standing start conditions we can think of. So this is what the power flow is from high voltage battery to inverter to MG2 to compound gear set and to final drive. So provided like it has that, and then means basically to wheels. So again, with different conditions, like if torque demand is increases, so it's like the condition would be like there is a scale. Sharon, yes, any question? Okay, so like MG1 starts the internal combustion engine to assist, and then MG1 generates additional power for the MG2. So that is what a light load, we can say, constant standing part. So now this is next phase, let's say like light constant load, but yeah, the speed is there already. Vehicle is traveling at medium speed driving. So in this mode, vehicle operates at medium speed with a constant load, such as cruising on highways, let's say, and there are no hilly terrains or something like that. So it's at constant rate. And so no slopes perhaps. The IC engine provides torque to power the vehicle, while MG1 helps recharge the battery via planetary gear set, I would say. So that is what the typical mode is. If battery is state of charge, perhaps SOC term you might have heard of and might have learned in these workshops. So I don't know. But yeah, state of charge is low and MG1's RPM is increased to prioritize the charging then in that case. So this is what MG2 is, and MG1 would be over here. So then it, of course, so depending on state of charge, so it would try to optimize the state of charge. So all these decisions needs to be wisely considered thoroughly while designing the codes and basically the algorithms for taking decisions in the ACUs and BMS systems, BMS ECUs and all. So that is what is basically sometimes very challenging. So power flow is from IC engine to planetary gear set and motion plus whatever MG1. So MG1 generates power for MG2 or charges basically the battery. So again, yeah, vehicles perhaps like Toyota Highlander, so hybrid version, which uses this mode efficiently on highways, which minimizes fuel consumption because I'm taking the name because I know the functionality is quite efficiently used, especially this into that segment vehicle. Again, there would be there are researches about the algorithms and all which would enhance this behavior further by taking into account, let's say, like ADAS functionalities and all. So depending on the levels of the ADAS, so of course this would be further changed or maybe a bit different. For high acceleration, which is a power demanding mode, I would say. So when vehicle requires a rapid acceleration such as overtaking or sudden speed changes, then system enters into heavy load mode. So in this mode, MG2 operates. So motor gear set 2 operates at a maximum output to provide a rapid torque delivery. So priority is torque in this case, not now the charging of the battery. So that's why it happens. Then IC engine assist engaging through compound gear unit. So let's say, and then while MG1 generates additional power for MG2 and maintains that optimum performance. And all this is, of course, driven through this control unit. So again, and this is essential for high performance driving situations where both speed and efficiency are crucial, I would say. So this system would ensure like that MG2 delivers maximum torque while minimizing the reliance on the IC engine and to improve fuel efficiency further. So that can be one of the scenario. Even maybe Porsche Panamera E-class hybrid vehicle. So that is also uh, because we know like it's Porsche makes a sports segment cars and that it is popularized into that. So that also utilizes this mode to deliver exceptional acceleration while maintaining fuel efficiency. Yeah, deceleration or power train mode of operation, let's say like regenerative braking one. So during this deceleration, the system enters into regenerative braking mode, as I've said. then like IC engine turns off and wheels transfer the mechanical energy to MG2, and then functions as a generator, I would say. So rapid battery charging and reduces wear on hydraulic brakes and regenerating deceleration force. So to prevent overspeeding of MG2 and gear units, IC engine may start to stabilize RPM of that. So because we are into deceleration mode, so to reduce the traction force or to transfer the force to wheels, it may come into in between. Reverse mode, yeah, so this is also important one. So wherein we know perhaps sometimes more torque is required at this mode. So in reverse mode, the system operates in reverse polarity through MG2, again allowing the vehicle to move backward without requiring additional gearing. So the IC engine remains off during reverse motion, and again MG1 rotates freely without generating a power. So that is what it basically use. Even there is a vehicle by Nissan Leaf, what is called, so that uses simple and efficient reversing mode mechanism to provide smooth backward motion without needing to separate the reverse gear mechanism and all. So that is one of the cutting edge technology these guys are using. EV mode, okay, so like pure electric vehicle mode. So that allows vehicle to operate using electric power only, of course. So with combustion engine is basically locked out. So we can see the symbol, so or symbolic presentation. So this mode is ideal for zero emission zones or areas with strict environmental regulations in developed countries, Europe and Pan America, perhaps. Yeah, they do follow, though not popular perhaps in, but yeah, that facility is there. Yeah. So even though the vehicle speed and range are limited, so if the battery state of charge drops too low, or the driver demands high acceleration, the system automatically switches to different mode from this. So that is what EV mode is in short. So I would say the summary of all the operations. So sorry. Operational modes. So we discussed about hybrid powertrains, which utilize various operational modes, optimizing energy using across different driving conditions. So like high load, light load, constant load, heavy acceleration, regenerative braking, reverse mode, and EV mode. So this is what each mode would be and is designed to deliver most efficient power contributions. So these are typical use cases, broadly listed, though when the moment we go for code generation and all, basically the system architecture design and all. So yeah, okay, so in that again, that the scenario would be different, I would say. Yeah, so then there are few mechanical challenges I would just quickly touch upon, which are essential for EVs, especially while handling the components and all. So I want to go into much details about that, but yeah, the hybrid vehicles, similar to traditional internal combustion engine, do have these components. So they are identical in most ways, so come with unique mechanical challenges, so that require special acknowledge and diagnostic procedures and all, and again challenges from the integration of high voltage systems. So that is also there, along with mechanical wear and tear, so oil lubrication issues, overall complexity of hydraulic or hybrid powertrain architecture, I would say. So these are basically key challenges into it. So speaking about safety considerations, of course, I have already stated above 650 volts or something or 60 volts above, whatever it comes, it has to be catered into much more safety priorities and all. So again, there would be separate different standards followed for these functional safeties as well as user safeties. So it's top priority in hybrid vehicles, of course, due to presence of live high voltage systems and powerful magnetic fields. So even technicians also are required to follow strict safety protocols to avoid the exposure to danger voltage or electrical faults. So that is a quite challenging part for maintenance and as well as the EV its life. So or even these hybrid vehicles life. Common challenges would be like we know like rotating components, so bearing failures, sealings, and all that, especially the coolant and all, or even wear and tear of the rotating components. Even like we do have planetary gear system, so of course like cooling of that is additional challenge even because of the friction and all, so heat and all. So again, it's bit high, and we know like sometimes this component do rotate at 17,000 rpm, which is a massive speed. So creating heat and friction is so that can cause a premature wear. So that is also a challenging part. From lubrication side, they recommend to go with only certified coolants and certified fluids because of the peculiarity in the component design and all. So yeah, so that is also proper lubrication in critical hybrid vehicles will ensure the smooth operation and prevent mechanical failures. So that is also essential. For cooling systems, yeah, thermal management systems are there for multiple components, but yeah, of course, those needs to be triggered and like smartly, so which can optimize the performance, even like IC engine, electric motor, battery, inverter, and all. So those are also primary parts into this cooling systems and all. Even about, since we have still IC engine and its rotating components, so of course their noise and vibration part, that analysis is also challenging into this in the presence of high electric and magnetic fields especially. So yeah, so that is also one of the challenge, I would say, for vehicle design. High voltage component system, yeah, we do have spoke about like specific accessories and all required from the maintenance perspective and all. So like to prevent stray currents through bearings and all. So it's basically very challenging part. So these are like challenges which we are listing. Fault replication and test drive. So that is also like monitoring for like noise, vibration, performance issues. So these are also a bit challenging. So I will just quickly go through one of the important part, maybe just 5 slides about the recent trends in lithium technologies, lithium battery technologies, I would say. So these are also these days becoming critical ones. So because we know like the entire war is about to optimize the technology of lithium and all. Any issues? Okay. So lithium ion battery is basically it's like default choice for EVs. Earlier there used to be like acid batteries like AGM, lead acid based batteries, absorbent glass mat, what they used to say. We know like these days lithium ion is irreplaceable because of the weight to performance ratio, we would say. So if we compare with conventional AGM batteries, it almost takes for the same amount of amperage. So it takes like half of the weight. So of course it is much 50% lighter than AGM and lasts longer. So if we see at the performance curve, even look at the number of cycles. So of course it is providing advantages to be into this. So again, there are based on chemistry and all or chemical changes into it. There are three typically used compositions, which is LCO, lithium cobalt oxide. So commonly used in like mobile phones and cell phones and laptops, whereas nickel, manganese, cobalt, and LTO, lithium titanate. So these are favored for high energy because of their high energy density and all, and fast charging capabilities for EVs. So I guess Tesla uses that NCA part, nickel cobalt aluminum battery, so which is high performance battery, provide long battery life as well as high energy density. So yeah, this particular unit is one module, and like that modularized structure they do have. But yeah, we cannot go on making it infinite in amount, of course it causes us a weight. So this I know, like in Tesla and all those cars, this itself, the battery pack itself weighs somewhere around 400 to in the range of 400 to 500 kgs. So that is huge in weight. So that dead weight we are carrying, so of course it increases the curb weight and all. So apart from that, yeah, battery management system and maintenance, that is also is one of the essential part for ensuring safety and efficiency in the operations. So BMS, like battery management system, would regulate the typical operating temperatures, voltages, charging rates, and all like into the safety for the longevity of the safety of the battery. So these are like some of the things. Future trends, of course, like the global EV market is projected to account for 25 to 50% of all vehicle sales by 2030. So the growth is driving continuous advancements in battery chemistry and safety. And again, perhaps like many companies have started tying up with Tesla is tying up with Google, IBM, and all for the quantum computing labs and all, and just to search for like different possible solutions or alternatives in different chemical arrangement or molecular structural base, like solid state lithium batteries. We have lithium sulfur, lithium air batteries, so which is cutting edge technology in China. So they are experimenting a lot in lithium iron phosphate based batteries and all. So that is what basically from the battery side I would say. So just a last part maybe. So just 2 slides or 3 slides of that. So which is about understanding the uh, traction motor, I would say. So and yeah, this is important because in EVs, this is considered to be the prime mover of our power. So in the like powertrains and all. So being we are discussing into hybrid technology, so or power driving part, so that's why I'm introducing it. So of course these are like crucial components in EVs, providing necessary power to drive wheels and axles. So there are different types into it: AC induction motor, and which can be used as a traction motor, even permanent magnet PSMS, like BLDC, brushless DC motors, even SRMs. So these are all possible solutions which are given as a traction motor. We also have our traction motor which do not use rare earth materials, which basically is permanent magnet and all. So ZF has got a patent on that and award for that. So for saving the environment and all. So yeah, for inside the traction motor, we do have these IGBTs which will control the performance, and it's all working principles and basically working environment and all. So in general, like that is what AC induction motor, and yeah, IGBTs is inevitable part of that. So basically it controls, it takes decisions and all. PSMS, so this has if we speak about this, it's characterized by permanent magnets, of course. So that is what it means, PMSM, sorry. So which has a rotor and electromagnets as in the stator and all that part. So BLDC. So this is what different configurations, but yeah, again, they use electronically or communication to control the current through stator windings and resolver assembly. So that determines the rotor position, and these motors usually offer high efficiency and reliability with minimum friction because of air gap. So SRM, so this also operates by minimum reluctance between stator and rotor poles. So through magnetic flux. So these motors do not use windings again or magnets on rotors, which makes them inexpensive and robust ones. So, but yeah, SRM struggles with lower torque at low speeds. Okay, so these are comparative studies and all. Yeah, these are possible arrangements, primarily three different arrangements we can see here. So those are possible, and again, as I have stated, like different manufacturers will go for different solutions. But yeah, these are like some key technologies into it. So yeah, that's it. If there are any questions, yeah, we can take. I don't know if we have time. If other presenter is already there, yeah, I would drop up then.
So if any participant is having any question and want to interact with sir, please unmute yourself and you can interact.
Hello, sir.
Yeah.
In one slide, you have shown different color of cell. That is only for visualization, or that is in a color coding for the cell.
Sorry, your voice is quite low. I will
Sir,
increase.
in one of the slide, you have shown different types of cylindrical cell.
Mm-hmm.
That is
Yeah.
color is only for visualization in PPT, or there is any color coding.
For sales, you meant?
Yeah. No, in
Battery
one of
cells.
the battery cells.
Okay, okay. No, no, no. There is no specific color coding as such. Yeah, some of the organizations do follow of their own, but yeah, it's not the convention, or I would say from the authoritative terms or something like that, which is not obligatory, I would say.
Okay, okay, okay. Thank you, sir.
Hello, sir.
Hmm?
Hello.
Yes, yes, you are audible.
Thanks for a very nice presentation and point by point. I would like to know one point. Under HPT, there is hybrid powertrain, which is the
Mhm.
preferred motor out of AC induction, brushless, or permanent magnet and the like for a given set of conditions and performance expectations.
Mhm. So you meant different types of motors or what?
Out of the different types of options that are available for
Mhm.
hybridization aspect, which is the preferred motor?
Okay, okay. Yeah, that preferred, I would say it all depends on the like different demands and segments of the vehicle. It is really tricky to answer this question because different segment vehicles like passenger cars and for commercial vehicles and all, it would be altogether different. So there is no one fit solution for all, something kind of like that. So but yeah, it all depends on the perhaps the the OEMs, manufacturers, and their segment of the vehicle, how the internal architecture is managed and all.
Yes, thank
So
you, sir. Thank you, sir. This was
yeah.
the Maghonikar from this college. Okay, sir.
Okay, okay. Yeah, thank you
I
for
just
your
one
question.
observation for the coordinators. I
Mhm.
have put the question, but it is on typing. It is not visible. There's some problem. Only name
Oh,
is visible and this is not visible.
okay, okay. Understood, understood. Yeah,
This is
thank
for
you
the
for your
coordinator. There
questions.
seems to be some problem.
Sir, okay, good evening, sir. Can I
Yeah,
ask one
good evening.
question?
Yes, yes, yes. Sure, sure.
Sir, you have given excellent topics on operating modes of EVs.
Mhm.
But my question is, in this operating modes, is there any forward and backwards? Is there any time duration is there by going forward and backward?
Correct.
Or
Okay. Okay, okay. Okay, understood. Yeah, it's a good question. Like basically the entire development or entire ECU coding is based on that to optimize or minimize the amount of time required. Usually we count that as in milliseconds. So of course, like as far as possible, like few milliseconds, it has to take time to reverse the direction of flow. From the prime mover side, from the component side. Okay, so of course it may not be possible directly that a vehicle, so if the shaft starts rotating in adverse direction, that does not mean immediately the wheel will start rotating. Yeah, it will take some time because there is some additional what we say like a traction force and as well as the weight of the vehicle which is already acting on that. So of course there is a lot of force and weight on the wheel, and it has to tackle to that. But yeah, it has to be in milliseconds. So based on that only, these segments of luxury comfort vehicles and the sports segments are classified. So for sports segment vehicles like BMW and Porsche and those kind of vehicles, of course you can imagine it would be few milliseconds and relatively less compared to all other segment vehicles. But for Mercedes and those class of, or even few class of like Stellantis vehicles, it won't matter. Like to it, of course it has to be minimum, but yeah, so not like sports segment, I mean.
Varsha madam, we will take one more question and we'll end that.
Okay, sir. Okay. Is there anyone who want to ask any question to sir? Swapnil sir, there is one question in a chat box. I will read it for you. Okay.
Okay, sure.
So what is the difference among variable ratio control, torque multiplication, and gear system?